What if I told you there's a secret blueprint to modern AI? A kind of treasure map curated by one of its most important pioneers, Ilya Sutskever. A map that lays out the entire story of how we got to now, and more importantly, where we're headed. Well, that's exactly what we're about to dive into. See, Ilya Sutskever himself basically said, if you really master these papers, you'll get it. You'll understand 90% of what actually matters in artificial intelligence today. So this isn't just some random list of articles. It's the master key to understanding this massive technological revolution that's happening all around us. So you ready? Let's unlock the first door. All right, so where does this whole journey even begin? Well, it starts with AI's first massive challenge, just learning to see the world the way we do. It's a story about moving from pure cold logic to actually understanding things through sight and language, from pixels to prose. Okay, so think about this. How do you teach a computer to see a cat? The old way? Honestly, it was a total disaster. Programmers would sit there and try to write out all these specific rules, like a cat has triangular ears. But what about a cat whose ears are folded or one that's looking away? It just failed constantly. But the new way, the deep learning way, is just genius. You don't give it any rules at all. You just show it a million pictures of cats, and you let the network figure out for itself what the very essence of catness really is. So how does that learning actually work under the hood? It uses something called a convolutional neural network. Now, the best way to think about this is to imagine the AI is in a pitch-black room with just a tiny little flashlight. At first, all it can see are simple things, a straight line here, a patch of color there. Then another layer kicks in and starts combining those lines into basic shapes, circles, squares, corners. And finally, a third layer puts those shapes together to see complex objects, like an eye, a nose, and then the whole cat's face. It's building understanding from the ground up, piece by piece. So AI could see. That was a huge step. But teaching it to understand language, that was a whole different beast. And the biggest problem was that early AI had this terrible case of amnesia. I mean, it would literally forget the beginning of a sentence by the time it got to the end, which, as you can imagine, makes having a real conversation pretty much impossible. So this problem kicked off this super rapid evolution in AI memory. First, we got what were called RNNs. They had a tiny short-term memory, kind of like reading a stock ticker one word at a time. Then came LSTMs, which were a huge upgrade. They added a sort of filing system so the AI could decide what was important to remember. But the real game changer, the one you've probably heard of, was the transformer. It just stopped reading word by word and learned to look at the entire sentence all at once. And this is the breakthrough. Seriously, the transformer is like a detective who, instead of reading a mystery novel page by page, just rips out every single page and pins them all to a giant wall at the same time. It can instantly draw these red strings connecting a tiny clue in chapter 1 to the villain's motive in the final chapter. This incredible ability to see every connection at once is called attention. And that right there, that's the core engine that powers things like ChatGPT. Okay, so with the transformer, we had the perfect engine, the perfect architecture. So the next phase of the AI race became about one thing, and one thing only: scale. This is where we enter the era that's really governed by a simple, powerful idea: the law of more. With this incredibly powerful new tool in their hands, researchers at the top AI labs started asking this one deceptively simple question that would completely change the course of technology. The question was just, what happens if we make it bigger? And the answer they found was just mind-blowing. They discovered what we now call the scaling laws. And what this proved was that getting a smarter AI isn't some black magic. It's a predictable formula. It's a recipe. You add more computing power, you feed it more data from the internet, and you build a bigger AI brain. And predictably, mathematically, you get a smarter AI. It was like finding a Moore's law, but for intelligence itself. But of course, this incredible discovery immediately created a brand new, very big problem. These new AI brains were getting so massive that they literally could not fit on a single computer chip anymore. Progress was about to slam headfirst into a physical wall. The solution was just a marvel of engineering. It's called G-pipe, and the easiest way to think about it is like a car assembly line, but for an AI's brain. You basically chop the brain up into a sequence of pieces, you assign each piece to a different processor, and then you just stream data through the line continuously. This keeps thousands of chips all working together in perfect harmony, and it let us build AI models that were way bigger than any single computer on the planet could handle. And this breakthrough brings us to a really profound shift in what AI is even for. The goal was no longer just about building a tool that could understand language. It became something much bigger, using this newfound intelligence to simulate and understand reality itself. And you can see this play out in the real world in a pretty staggering way. Take discovering a new drug. The old way meant firing up a supercomputer for weeks just to try and simulate the crazy complex physics of a single molecule. The new way? An AI can essentially just intuit the properties of that exact same molecule in milliseconds. This isn't just a little bit faster, it's a completely new paradigm for science. So how did it do that? Well, the big breakthrough was realizing the AI didn't have to be a physicist. It didn't need to calculate all the impossibly complex physics equations from scratch. Instead, it learned to treat molecules like a social network and just predict the outcome based on the relationships between all the atoms. This is explained so well with what's called the gossip network analogy. Picture this. Every atom in a molecule starts out knowing its own little secret, like, hey, I'm a carbon atom. Then it whispers that secret to its immediate neighbors. Those neighbors then update their own status based on the gossip they just heard. And after just a few rounds of this message passing, every single atom in the network knows what's going on across the entire molecule. The AI can feel the physics without ever having to solve an equation. It's amazing. Okay, so all of this incredible progress, from seeing cats to simulating molecules, it's all building towards something. And this final part of the blueprint is all about exploring that ultimate destination, the superintelligence endgame. But before you can even try to build a superintelligence, you've got to define what intelligence actually is. And this is one of the best definitions out there, from DeepMind co-founder Shane Legg. He says intelligence isn't one specific skill, like being great at chess. It is the ability to achieve goals in a wide range of environments. It's about general capability. It's about being able to adapt to, well, anything. So, how in the world do you measure that? Well, the true metric, the real test of intelligence, turns out to be compression. Think about it. An AI that can watch a million apples fall from trees and then distill all of that chaotic data down to one simple, elegant rule, gravity, that AI has achieved true understanding. It has compressed the chaos into a simple pattern. Better compression equals deeper intelligence. And this all leads to this wild, almost philosophical way of looking at the entire universe. Think about pouring milk into your morning coffee. At first, you have simple order, right? The two liquids are totally separate. Then, as you start to stir, you get this incredible moment of rich complexity, these beautiful swirling tendrils and patterns. But if you keep stirring, it all just becomes a simple, uniform, boring brown liquid. Simple disorder. Our universe right now is in that beautiful, complex, swirling phase. And by building artificial intelligence, we're pouring gas on the fire, accelerating that journey, creating systems that are even more complex than we are, pushing that peak of complexity higher and higher. So the final mind-bending question this blueprint leaves us with is this: are we building the final architects of our universe's most complex and most interesting moment?